Good morning, class. Welcome to another learning session in General Mathematics. Our main topic for today is about evaluation of functions. Our learning objective: at the end of the lesson, the learner is able to evaluate functions and solve problems involving functions. So what do you mean by evaluation of function? Evaluating a function means replacing the variable in the function, in this case x, with a value from the function's domain and computing for the result. To denote that we are evaluating f at a for some a in the domain of f, we write f of a. So basically, evaluating a function is simply determining the value of the function at a particular domain of f. So to illustrate the concept, example number 1, evaluate the following functions at 1.5. Alright, so let's solve this one all together. So for letter A, we have f of x. Let's write first our given function, 2x plus 1. We will be replacing x with 1.5, and we will be solving the value of the function f at 1.5. So that means replace all x with 1.5. So 2 times 1.5 is 3 plus 1, that 3 plus 1 is 4. So that's the value of the function at 1.5. Letter B, you have given function q of x equal to x squared minus 2x plus 2. We will be solving q of 1.5. That means replace all x with 1.5. So 1.5 squared minus 2 times 1.5 plus 2. 1.5 squared is 2.25. 2 times 1.5 is 3 plus 2. We have negative 3 plus 2 is negative 1. So this is 1.25. Alright. Letter C. You have g of x equal to the square root of x plus 1. We will be solving g of 1.5. So basically that's square root of 1.5 plus 1. 1.5 plus 1 is 2.5, and this is already the result. There is actually no exact value of this one. By the way, this is 1 point. Alright. For letter D, go to letter D. We have r of x equal to 2x plus 1 all over x minus 1. R of 1.5. That's basically 2 times 1.5 plus 1 all over 1.5 minus 1. And we have 2 times 1.5 is actually 3 plus 1 over 0.5. So that's actually 4 over 0.5. And actually 0.5 is just the same as 1/2. So when we divide fraction by a fraction, we can simply change the operation to multiplication, but we just take the reciprocal of the divisor. The reciprocal of this is 2 over 1. So that's basically equal to 8. And lastly, we have, and this is a very important concept, the greatest integer function. So the greatest integer function of x plus 1. By the way, the greatest integer function is actually the greatest integer less than or equal to the given value of x. For illustration purposes, for example, the greatest integer function of 3.2 is again the maximum or the greatest among the integer less than or equal to this value. So we have the integers are 3, 2, 0, and so on and so forth. The maximum of that is simply 3. And same is true with 3.7, for example. The greatest integer function of 3.7 is take the maximum of all integers less than or equal to this value. We have 3, and actually they're just the same. So on. So this is 3 as well. So if we will be solving f of 1.5, so take the greatest integer function of 1.5 plus 1. The greatest integer function is actually equal to 1 plus 1, so this is equal to 2. Alright, there you go. Okay. Evaluate the following functions where f and q are as defined in example number 1. Okay, so let's solve this one all together. Let's write our function f of x first. I believe our f of x, 2x plus 1, so 2x plus 1. Right, so we will be replacing x with this one, the 3x minus 1. So that means this x will also be replaced with 3x minus 1. And then we have plus 1. So we can actually multiply 2 times 3x. No, multiply, that's 6x. Multiply, so that's minus 2 plus 1. 6x minus 2, negative 2 plus 1, that's negative 1. So that's the value of the function at 3x minus 1. That's for letter A. For letter B, we have to write first our given. Our given is x squared minus 2x plus 2. So x squared minus 2x plus 2. We will replace x with 2x plus 3. So this is 2x plus 3 square minus 2 times replace with 2x plus 3 plus 2. Okay, recall in your junior high school, if you have to take the square of a binomial, just simply take the square of the first term is 1, and for the middle term, actually the result is a trinomial, no? So for the middle term, multiply a and b and then multiply it with 2, so 2ab, and for the last terms, just simply take the square of the last term. So that's actually the pattern. So going back with our problem, the square of this following this one is simply 2x squared plus 2 times 2x times 3 plus take the square of the last term, which is 3 squared, and then you can actually multiply per term, so that's minus 4x. Negative 2 times 3, that's negative 6 plus 2. So we have 4x squared plus 2 times 2 is 4 times 3 is 12, so 12x plus 3 squared is 9 minus 4x minus negative 6 plus 2 is negative 4. And then we have 4x squared. 12x minus 4x is 8x. 9 minus 4 is 5. So this is now the result, 2x plus 3. Now, let's have this one as our last example. The function for the height of an object dropped from a 100-meter tall platform at time t seconds is approximately given by this equation. Given by that equation. What is the height of the object after 2 seconds? That's after 2 seconds. So just solution. Basically, you can just simply imagine if this is 100 meter tall. The object is object is actually falling. Whose height is actually determined by this. So if we're going to determine the height at 2 seconds, just simply evaluate the function at 2, negative 5 times, so that's negative 2 square plus 100, so negative 5, 2 square is 4 plus 100, so this is negative 20 plus 100. Sorry, this is 100. This is 80. So meaning after 2 seconds, so imagine the ball is already right here, where this is already 80 meters now from the ground, at 2 seconds. Okay, so therefore we can make a conclusion, because this is a problem solving. After 2 seconds, the height of the object is approximately 80 meters from the ground. All right.